Hi, everyone. Hey, Jeremy. Hey, Josh.
Hello. Happy Tuesday.
Howdy. You know, Thursday used to be my meeting hell day. It's shifted to Tuesday now.
But you still only have one. That's a positive.
Well, the meeting hell day is the day on which I not only have meetings straight through from 7 a.m. until noon, but in fact I have several conflicts within that setup.
Oh, that's always fun.
So you have the recurrence of difficult choices around those conflicts.
I have the recurrence of, hey, have you put up the agenda for the meeting? I need to decide which one I'm going to skip. Except in this time slot, at least for the first half hour of this meeting, I have no conflicts.
Well, that's nice. Some slight break.
Yeah.
All right, we'll give it another minute for folks to join. Richard, I see your nick in the chat. Are you the same Richard that put an item on the agenda?
Yeah, that's me.
Okay, great. All right, well, why don't we go ahead and get started. This is the August 11th SIG Multicluster. Richard, you're first on the agenda with the Loblaw project or
Sure.
multicluster model.
Yeah. So should I share my screen?
That would be great. Oh, I probably need to enable you to do that.
Yes.
All right, you are enabled to share your screen.
Perfect. So I just threw together a quick, slide deck, maybe, 10-minute presentation or so. For those of you who don't know, I guess it's my first time here. So my name's Richard, and I work at a company called Loblaws, and Loblaws is quite a big retailer in Canada. So we have things like loyalty programs and quite a bit of Canadian traffic, and so we've chosen to run our workloads on Kubernetes primarily. But I wanted to cover a little bit about what we saw in our line of work as it pertains to multi-cluster and some of the approaches that we went down and tried to explore. Definitely, I only learned about SIG multi-cluster a couple weeks ago, so we've been hard at work reading up on your documentation and your position statements, and I thought this would be a great opportunity to share our notes as it, as we come across it. So
That's fantastic. Thank you. This will be really interesting.
awesome. So our sort of because we are part of a larger enterprise, there are a couple of architectural requirements that were sort of handed to us, and our challenge was to design sort of our cluster or multi-cluster solution based around this. So the first thing is a private network, sort of the private IP space has to be. So we couldn't use a lot of say service type load balancers out of the box, because we need a firewall at all points of ingress into this private network space, and that's sort of how a lot of these out of the box solutions start to break down, is when you need to put a layer in between your load balancer and the internet. And configurability historically has been sort of a struggle for us. We need MTLS between clusters and workloads, and I know that this SIG isn't specifically for meshes or whatever. I saw Tim's comment on how we're trying to build building blocks for these meshes, but sort of just a point there. We're working off of a single region container native routable solution, and also we are using Istio as a service mesh. So that is our main method of ingress after all of the firewall stuff and the north-south stack. So the main problem statement that we wanted to solve was that upgrades on a cluster-wide basis is very terrifying if all of your workloads are on that same cluster. So anything that requires a control plane, anything that requires custom resource definitions, right? When you touch that resource definition, inherently the whole cluster gets impacted by that. So, we thought about how can we limit that blast radius of a tool, or Istio or any of the other platform tools that we rely on. And so we thought about, what if we blue-green the cluster? And so this was a little bit of a roadmap, or sort of the algorithm that we wanted to follow as we went ahead and blue-greened our clusters. Obviously phase 0 is creation of the green cluster, make sure that the clusters can connect, and then make sure that services are discoverable, and then finally a north-south switchover on the ILB, and then finally decommissioning of the blue cluster. That's a lot of points, so I sort of drew a diagram to help everybody understand what I mean by that. So we have blue clusters and green clusters, and I especially appreciated your statements on namespace sameness, right? Where tenant 1 and tenant 1 here, both clusters should be the same, and at least look the same in any consuming service, and also tenant 2. So specifically, because I talked about MTLS with our service mesh, the only cross-cluster discoverable service that in our current design is the ingress gateway, because when blue cluster needs to connect over to green cluster, the MTLS is verified via the ingress gateway and how those interact with each other. And then the last point of ILB switchover, or the north-south switchover, is really about the internal load balancer up here. So phase 1, I think, is kind of less relevant to the work of this group, because it's mostly about sort of signing certificates and rotations and stuff like that. Phase 2, which was the service discoverability, I thought was bang on with the work here at MCS API. as I said before, the only service that we need to be discoverable between two clusters is the ingress gateway. And so we actually ended up writing our own service that watches service and endpoint events and then takes the definitions and reapplies them to another cluster. It's relatively quick and dirty solution. I have also made the source code available, but I would be really interested in, and I've already started a little bit of it, comparing the two approaches and seeing how similar or how different they are. And here's, I guess, one of the questions that I wanted to discuss today is like, I don't know if I'm missing something in the documentation, but I couldn't figure out how clusters were actually registered with each other because
sorry, go ahead. I didn't
go
mean
ahead,
to interrupt. Yeah. I was just going to say that's a really good question, and the thesis of our SIG multi-cluster intro is that cluster registry is easy to describe like as a thought.
Right.
In practice, it's been super difficult to build something that makes that idea real in software. And one of the things that characterizes our approach that we're taking in the SIG right now is that there is an existing project out there called the cluster registry that's in the Kubernetes GitHub org. But we really, I think, sort of put the cart before the horse with that one. And we have two things happening right now. One is we have a world writable document where we're trying to collect specific use cases that people have for registration as part of like a rethink of the concept. And the other one is that in multi-cluster services, and I think you've kind of happened onto this dimension, but it's also in the work that we've been doing on the work API, is that we're trying to avoid prematurely characterizing a registry and overfitting to the problems that are directly in front of us. So I would be super interested in use cases that you would characterize for what you think registration means and what would you want to do with it.
Right. I think just in terms of thinking about the problem set of MCS API, first of all, I guess I'm interested in how the sort of implementation right now does it. I know I was able to find that, declaring a service import does indeed import a cluster. I'm just a little bit confused as to where it sources that information right now as it stands in the GitHub.
Right. Jeremy, you're probably best posed to answer that one.
Yeah. So this kind of goes in the building blocks first approach, but basically, like we've hand waved away the cluster registry for now with MCS, we've also hand waved away the actual implementation. So we've created the CRDs on both sides, then we've defined the behavioral spec for how you map service export to service import, but there is no canonical implementation for how that actually happens. So there's a spec for what an implementation should do when it sees service exports in your clusters that are attached to your imaginary cluster registry that we will have also one day, and the service imports that should be created. But yeah, that canonical implementation doesn't exist. But I know that like Submariner has been looking into this and what that would look like, and I know that there's a bunch of issues open to implement the API. And there's actually, so this is something that is probably even more relevant to you, but I know that Istio has been interested in implementing the API as well. So I don't know if you've talked to the networking working group or anything with Istio, but yeah, so there is no implementation today for how it's done. But the assumption and hope is that there will be multiple, but that they will behave in similar ways, according to the spec.
Yeah. I mean, so I'll sort of go over briefly how we decided to solve the problem, and I don't think it is the best way, but it was sort of the first to mind, was basically when we install the service, we target another cluster. And that was sort of our quick and dirty method. And one of our thoughts going behind that is like a service registry is another sort of moving part to it. It seemed to fit our, we're a relatively simple where there's only ever 2 clusters at once. So obviously that won't fit everybody's use case. But
So
go ahead.
I'm sort of trying to line up your description just a moment ago with the content on the slide. And when you say that you target another cluster, would that be like the blue one knows about the green one or vice versa? And so,
Right,
your service syncer thing is just copying from the target?
Right. So it would be a service primarily on the green cluster that would copy its services into the blue one, because primarily we wanted to touch the blue one as little as possible during the changeover. Obviously, for rollback purposes, if we could just kill the green cluster and leave our blue running in production, that'd be amazing, right? So we wanted to install as little as possible in terms of services on a blue cluster, but still have it routable over to the green, if that makes sense.
So I think it does. I'm hearing you make a new green cluster when you're going to do a deployment. You make a new green cluster. It knows about the blue cluster.
Right.
Once your checkout process on the green cluster gives you the green light, there's a piece of software that lives on the green cluster that's programming the blue cluster.
Right. Exactly. Yeah.
Okay.
That's a good characterization. Yeah. And the other part I wanted to touch today was the sort of the phase 3 of it, which is the internal load balancing, the top from the north-south traffic. The other question I wanted to ask was, obviously the specifics of how the load balancers are handled is up to the cloud provider or external load balancing software. But do you guys have any thoughts on how sort of describing the behavior or how the behavior should be from the, and I say that because right now a service of type load balancer has one load balancer attached to it in a sort of single cluster way. When we expand that definition to more than one cluster, are we still having one load balancer IP, or will there be multiple, or do you guys have any thoughts on that?
This is a really good question. I think I've certainly had some thoughts. I don't think we've gotten there yet with NCS, and I think this is probably a good time to start this conversation. Actually, it's also a good segue because I think then one of the next items on the agenda for today, Andrew brought up the idea of node port multi-cluster service types and what that could look like. But I think we need to have a conversation about what other service types might look like. So what is a multi-cluster service type load balancer like? I think it seems reasonable that there might be one single load balancer IP that routes to the multi-cluster service across the cluster set, and then the mechanics would hopefully then be similar to a service type load balancer within a single cluster. But I think there's, with any of these external routing concepts, I think we have to figure out how do we actually describe that.
Right.
Like currently the only two service types are for a supercluster, or sorry, cluster set. I'm gonna probably do that for a little while now that we have a real name, but the cluster set IP and headless, and those are easy to derive from a service. But then
right.
how do you dictate that this should be a load balancer type multi-cluster service? I think it's a question that we need to answer, but we should answer it. So let's
Yeah,
start.
I think the context for us is like right now, of course, right now our toy solution is finding a way to manually manage that by using the external IP service type, and then just getting our load balancer to point to the 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 nodes, the node IPs of each different cluster, and because it's a layer 4, we don't have the opportunity to sort of do percentage-based routing or header-based routing or all of those other things, which is okay. But when I started digging into this field, it didn't seem like there was a right way to do it yet. And so it would be cool for this group to come up with a standard practice or a good practice.
So one of the things,
absolutely.
one of the things that like I'm hearing as we talk about this is there's beyond like the what our conversation at the moment is about. I think we're also trying to describe some properties of cluster sets themselves. And Jeremy, I think like you said a few words that like connected that in my brain. I wonder if this is a good time for us, maybe just like we have the open use cases for what do we think the properties of cluster registration are, and what do we want to do with like primitives around registration? If we should have like a similar open call for use cases for cluster sets, so that we've got a name, and probably people have different ideas about what do they mean. And maybe it's time to start writing down what do we actually want them to do and allow us to express.
Yeah, I think that's a great idea.
So an action item I can take there is to create a new open use case document, and I'll share the link on the list later on. EOF.
Awesome. Well, that's pretty much the end of my presentation. But I did want to say I was really excited to find you guys. It's this type of work, really needs a community around it, and finding you guys was sort of like, hey, it's not just me. I'm not crazy. But I'm really excited to be an active contributor in this group.
Thanks
Awesome.
a lot for the presentation. This was super interesting to me. So I really appreciate you coming and sharing your experiences with us. That's the kind of input that we really need to find the things that are going to be useful to provide from the community. So it's really appreciated. Thanks a lot, Richard.
Yeah, thank you. This was great.
Awesome. Thank
and
you
I
guys
think we've
for
started
the
a few conversations.
Yeah.
This is good.
Well, is that a good segue then into your MCS API update, Jeremy?
Yeah, and I think I'll go quickly because Andrew added a couple bullets that I think are probably more interesting. So I just wanted to let everybody know, and I linked it in the notes, but we actually have a SIGs repo now for the alpha implementation, which means we can take PRs. So there's some work to do before we can get to beta, quite a bit of work, obviously. We need some implementations for one. So that's a good place to start so that we can answer, hey, is there a canonical implementation? Yes, maybe, or multiple. So we have somewhere to point. DNS is a big open question that I think we've alluded to in the KEP. I think at a high level, it doesn't seem too controversial, but let's see about implementing it and see if that holds true. I think we'll uncover some surprises there. I would expect. And so if anyone wants to help, we actually have a place where you can. So PR is welcome. And I see that Andrew has PR1, which is great. So that took no time at all. So thank you.
Yeah, so as we're talking about like implementations, like I don't know what folks here think about cluster API and whatnot, but like yeah, like I can see a cluster API implementation being kind of like the maybe like an obvious candidate for this, because everything related to clusters is represented as CRDs in like what they call the management cluster. So it'd be kind of pretty trivial to just use that CRD as like the cluster registry and then go from there. So yeah, like if folks think that would be good, I can take a stab at that.
I'm wary of attaching to any provisioning thing with a hard dependency, because for example, we have a provisioning API that's not part of cluster registry that we use for OpenShift. As I understand it, also like the thing that is called cluster API in our upstream is not directly supported by any vendors. So I think vendors put additional APIs in front of that in order to use it. I think that's sort of a challenge that we'll have to cope with. And one of the things I've sort of wondered to myself if we should think about this as a principle is it a principle that we want the work in this SIG to be independent of any provisioning API? What do people think about that?
So I agree with that. I think cluster API is a little weird in that it is a provisioning API, but because everything's in CRDs, like you can layer anything you want on top of that. So like I don't see a cluster API implementation kind of violating that principle, because it's not like it's not strictly provisioning, I guess. But yeah, I think that in general, like I tend to agree with that we shouldn't couple two provisioning APIs too much.
Yeah, yeah, I like that as well. I do think there's probably room for like I can't tell if you're talking about like the just MCS or like a whole cluster registry. Like I think tying cluster registry to cluster API strongly might be.
Yeah, I meant just MCS.
So I think there's probably room for that. Yeah, I think like having an implementation of MCS based on cluster API could be interesting to see how that would look, for sure.
So is the just to make sure that I understand like what we would get out of that, is the draw because it's something that it is already built that we could avoid building something new, or is there some other property of it that makes it attractive?
From my perspective, it was mostly just like there's a project that implements clusters as CRDs, and so it would be an easy first implementation, or like we could use it as a reference implementation to actually go through the cycles of like implementing the entire MCS API and figuring out like what parts of the API feel awkward, what parts of it do we like. So that was really the angle I was coming from.
Gotcha. Yeah, it sounds like it's just convenience.
Yeah, partly.
Okay. Yeah, I think I'd probably just want to make sure that we don't let the apparent convenience of something let us skip a step on collecting, like, is there a cluster registration use case here? And exactly what is it?
Yeah, and I'd want to be wary about making changes to services to accommodate cluster API when they're not otherwise necessary, or making sure that the changes that we make are for the right reason and not to kind of go along with that convenience.
So is it cool if we maybe zoom in on what the registration use case is here? So it sounds like there is, like we're having this conversation because there's a registration use case. Is the use case, is it that we just need to have a record of like endpoints? Is it something deeper than that? Is it that we want to run a reconciler that will watch the list of clusters? Exactly what use case are we looking for from registration here?
So I'm missing a lot of context of the cluster registration. I also have a hard stop in like a minute, so I might have to drop. But
okay, well maybe that's. Go ahead. Sorry.
Yeah, but yeah, basically what I'm saying is like, yeah, like if a controller was implementing like the API that like reads the service import and creates a service export and all that stuff, like it would need to be aware of like, yeah, the list of clusters, and then based on that list, it should be able to like generate a kubeconfig or a way to access and to like talk to each cluster and pull information out of it. And so like cluster API seems like a good starting point because basically like any cluster resource represents a cluster, and there's a matching secret with this like admin kubeconfig, and so like that is an already good starting point where we can use that, pull in all the service exports, and then reapply the service imports based on that.
So I know you've got a hard stop. Maybe think about how you'd characterize exactly what the specific use case is, and why don't we talk about that in next week's meeting as like a good way to seed that use case doc.
Yeah, sounds good. It's the same with like the service type no port discussion. Like, yeah, like I have to drop now, but I'd love for people to kind of steep on that a bit, and maybe we can chat next week.
Awesome. All right. Thanks a lot.
Yeah, thanks a lot. So I think Andrew was the rest of the agenda. But I think thinking about these things is really good. Like I think out of that, it sounds like we've come up with a couple use cases for that cluster registry doc, and it'd be good to think about that over the next week and really get them down at the next meeting. And then also, you know, node port and then load balancer type 2. I think we should start thinking about what those service types could look like in a multi-cluster world.
Mm-hmm. So it's too bad Andrew had to leave. I'm sort of wondering if anybody else heard Andrew describing properties of a push scheme, where there's one thing that's getting an admin kubeconfig on the registered clusters and pushing to those clusters resources. Did anybody else hear that?
Yeah, that to me seems like anything built on cluster API would probably head in that direction.
So one of the lessons that like we at Red Hat take out of our initial experience in what we've done up to this point is that for a lot of users, it seemed like push had a couple significant limitations. That there was a perception that a push scheme is a single point of failure. So if you're pushing from some hub, that if that hub goes down, and you don't have a way for another hub to pick it up, that the hub is effectively a single point of failure. As just for my own subjective thoughts, like I find the term single point of failure oftentimes to just be confusing and to eliminate details and nuance where they're usually very important. So I am more relaying that as something that people have told to me rather than an articulation of my own personal opinion. But it does seem to be a concern that people have. The other one is that there are many environments that users have where push doesn't work for them for whatever reason because it crosses an addressability boundary. So many of the users that I've spoken with have topologies where their fleet is able to dial a hub, like they can dial externally, but they're extremely limited in terms of what inbound traffic they can take. And so that has kind of pointed my own thinking to be positioned around pull, where the difference between push and pull is that in push, you've got something that is reaching out and programming a cluster. And in pull, you have something running in the cluster that is instead of being pushed to, is reaching out to something else, like watching an API and pulling information from that and materializing that onto the cluster. So I am pretty roundly convinced overall that one or the other is not, like, we can't make a binary choice that will work equally well for everyone. So just wanted to call that out about push versus pull.
Yeah, and I think we made a strong point of including that in the MCS cap as well. The idea that push versus pull and centralized versus decentralized are, like, that was a key conversation. I think it's important, whatever direction we go, we should make sure that we're accommodating both.
I actually might have another viewpoint on this push and pull, primarily based on sort of even deployments and how we approach our CI is very much pull based, because we found that a pull based method of sort of artifact retrieval and other things, they just tend to be more controllable, right? Having credentials on on something that can push seems very dangerous to us, right? And so we prefer a pull-based methodology as well.
And that's another piece of feedback that we heard around previous efforts in federation, is that if you got a place in the control plane that holds admin credentials or cluster root credentials for a bunch of clusters, one, that's a really, really high value target that you've added to your API surface in that cluster. And related to that also is that there are, if you start to stack multiple use cases, like we're talking about connectivity and multi-cluster services now, but if we stack like scheduling onto that and maybe policy enforcement, that two things happen. One is that it becomes very clear that there are multiple service account like entities that are doing things at very different degrees of privilege. So we need to, I think, be careful to account for subtlety, nuance, and decomposition in terms of which service accounts are doing what for which use cases. And it's very likely that if we're running an agent that is programming network stuff, that needs a really, really different level of permission on particular resources within the cluster, besides or other, different than what I might need if my job is to deploy Helm charts, or if my job is to enforce a policy of some kind.
Right. And you probably don't want everything that's involved with multi-cluster to have read all secrets in all of your clusters.
Right.
As a baseline place to start. Like, I think, yeah, we're going to want to think about those different service accounts for sure.
Yep. Any other perspectives people want to present about that? We're nearing the end of our time, so maybe we're talked through, and I will, as an action item, besides getting all the videos uploaded, which I guess there's a bit of a backlog It's surprisingly difficult to get them uploaded and put into the playlist, but that is supposed to change soon now. Aside from that, I will open up a use case document for what do we think cluster set should mean and what should they do?
Awesome.
All right, sounds like we maybe talked through. Thanks, everybody. Thanks a lot, Richard, for joining us. And I will see you all soon.
Thanks, everyone.
Thank you.
Have a great day, everybody. See ya.